Hi folks, so today's question guys is based on the topic of rotation of objects, chapter 23 in the Understanding Technical Graphics textbook. It's on page 233. So the question itself says, the figure across shows the elevation and plan of a flag containing a logo. The design contains an equilateral triangle, okay, so we can see the equilateral triangle inside here. A regular hexagon and a regular octagon. So we can see the hexagon is inside here as well, okay, and then a regular octagon is also inside here. And also we can actually see that there's a circle inside it as well, and obviously it's contained within a square flag 120 by 120, and the flagpole is 35 up from the XY line. So it says the flag is flying in an easterly direction, so we can see elevation here. The plan view is obviously going east here. And what they want us to do is draw the given elevation, and then on the same XY line draw the elevation when the flag is flying in a southwesterly direction. Okay, so first of all guys, just on working out some of these shapes inside here, okay, this is kind of really bringing us back to our Polygon chapter on our understanding on polygons. So we can see here it's contained within a square, okay, so if we join the diagonals of the square we can see we obviously can get the center, okay, and the center will help us draw on the circle. Now we can see here that it's 120 high and it's 120 long, but the height here is important because we can see here on the outside for all of these kind of points in here, for the top of say the hexagon and the equilateral triangle and the circle, okay, we can see that they're kind of lined up here. And what these mean here is basically that they are equal measurements, and we can see we've got 1, 2, 3, 4, 5, 6. So 6 equal spacings of one, and that's 6 equal spacings of an overall height of 120. Therefore, just by a little bit of simple maths, we can work out that that is 20, 20, 20, 20, 20, and 20. 620 is 120. Nice and easy, okay? So the first thing we would actually start off with is maybe working out what the circle is, and we'd actually start with then maybe doing the equilateral triangle, okay, which is contained within the hexagon and the circle. So working out the radius for the circle, we can see once we find the center, up here to the top, we can see the radius is 20 plus 20 is 2 portions, because that guides all the way into here. So that means our radius of the circle is a radius 40 circle, okay, diameter 80. So that's nice and easy there. And then at that point guys, we know we can get our hexagon. First of all, hexagon guys is going to be at an angle up here. This angle up here guys, when the hexagon is sitting with its base flat, now we can see that it's not sitting technically flat, okay, it is a regular hexagon, but when its base is flat, okay, the exterior angle is going to be 60 degrees. 360 divided by the number of sides is 6, so 360 divided by 6 is 60 degrees. However, this is not actually sitting flat, it's sitting on its points, okay, and when it's sitting on its points, the actual angles it makes here, you can see this angle here is actually 30 degrees, okay, 30 there and 30 there, okay. So therefore the interior angle here is actually going to be 120, because we'd have 120 there, 30, and then 30 out the opposite side, okay. The exterior angle, as we know then, is, if I was to continue that line on, that edge there when it's sitting flat, okay, is 60. So we can actually work that out. So from the top of our circle and the bottom, we can just go at angles of 30 degrees and find our hexagon. And then, having drawn the hexagon, we can see we can clearly then draw in our equilateral triangle. So that solves the triangle, the hexagon, and the circle. Now what we actually need to work on is the polygon. And the polygon, very much like the hexagon, is actually once again not sitting flat, it's sitting kind of on its points. But we know from the center to every one of these points, okay, if we look at this one, this is actually going to be our guide. From the center to here, that is the distance from the center to there to one of the points. So from the center to there is going to be the same as from the center to here, center to here, center to here, here, and so on. So once I have actually got the center, I know the distance from here to here is the same as the distance from here to here. So I can actually just mark that with my compass, and then obviously mark it off along the diagonals 8 times. I actually have 4 points already starting out, but to find this one, this one, this one, and this one, I can take that distance there and literally just mark it along the diagonals to find them. Okay, so that's how we're going to start it there guys, okay. So, starting off that question, guys, you can see I've it already prepared. I've drawn in my flagpole, I've got my XY line, and then I've got the plan view of my line down here. And I've also drawn in the flag when it has been drawn in a southwesterly direction. So I've taken the 120 and rotated around, and I've kind of got the flag in its position over here in the elevation. But what I have to do is the detail inside here. So, as we worked out, each one of those is going to be split into 20mm heights. So I'll do it out here on this side. So just mark them. 80, I'm just marking up in 20s. Okay, and having done that, just put the lines across nice and lightly. Okay, now I need to find the center, and we know in the image of the diagram they've given us, they've joined the diagonals. Now, I'm assuming that's the center right there, okay? But for the sake of it, I'll just join the diagonal to prove it. Yeah, it's working out fine. There's our center, okay? So the first thing I'm actually going to start off with is the circle, okay? And I'm going to put in that circle there. So I'm going to put in a line here, just up to there like that. Because I know that distance from the center up to here is 40mm. Okay, so that's my radius of my circle that we worked out a minute ago. So I put in that circle, I'm going to put that in heavy. So there we have the circle. Now what we're going to do is we are going to draw in our hexagon. So this will be nice and quick. So for the hexagon, I'm going to put in 30 degrees there, and you can see where it's matching up. It's working out neatly here. Where it hits there and there, I'm going to project up. And then it should come down at 30 degrees, and yeah, this is matching up as well. So there's our hexagon. Once again, we're going to heavy that in. Okay, 30 degrees the opposite way. So just a little bit of understanding on polygons there. Nice helpful question for us. And finally, I will put in my equilateral triangle. So I know that this guy is heavy from there to there, and then this should connect up at 60 degrees here, and it does, so I'm happy with that. Hopefully it does on the opposite side. 60 degrees, yes it does. So there's our equilateral triangle. Okay, now as I said previously, for the regular octagon, I said I could take the distance from here to here. Okay, take that distance there, and I could mark it on the diagonals. So I can mark that one, mark this one, mark this one. So you can see that this is important because it's coming in just underneath our 20 marks. And at that point then, I've already got 4 points on it. I need to find 2 more actually. Forgot to extend this all the way up and this all the way down. And now I've actually got 8 points. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'll connect all of those up. And the exterior angle of a octagon is usually 45 degrees. Well, it is not usually, it is actually 45 degrees. 360 divided by 8 will work out to be 45 degrees. However, this is not sitting when flat with its base on the ground. Therefore, the exterior angle in this case is probably working out at 22.5, I think. I'm not 100% certain on that, must check my maths. What I'm saying there is that angle is okay. It usually is 45, but that's when I would extend this line out, and in relation to that, that would be 45 degrees. Okay, so there we have it. We have completed the elevation. Okay, now what we actually have to do is we are going to find these points, okay, over here when the flag has been rotated in a southwesterly direction. The one I'm going to leave till the very end is actually the circle, okay, because we already have the hexagon. There's actually 6 points we already have, okay, that are on the circle, okay, and we might find maybe we actually have a point here and a point here, okay. We might find 1, 2, 3, 4, just to be able to draw the circle in at the very end neatly and tidily, okay. So starting off, I'm actually going to start off with the points on the octagon, okay, and I've already actually got 4 of them. They're literally on the outside edges, so technically that's 1 and that's 2, and then this one and this one I need to find them, okay. So I'm going to start with the octagon, build it in stages. So this time, last time I started inwards and I went outwards. This time I'm going to go outwards and back to inwards. So for the octagon, just get those points there. So that one come up to here, and then all the way up to the top. It says 2 more, and now project these down the go. And then these 2 points. So you could use labels if you wanted. And about here, just make sure I'm as accurate as possible. This will be a little bit easier obviously with a pencil, but just for the purpose of the video, I'm trying to make sure my lines are clean and tidy and can be seen. So rotate them around, and once again I'll just switch up my set square there, go to the larger one. So that'll go all the way up to about there. This guy will be the same. There you have it. Okay, and to be able to complete that, then these 2 points here, which line up, that'll give us 2 more points there, and the exact same at the top. So that'll give us 2 more points. So at this point now, I'll actually heavy in my octagon points. So from here to here to here. Right there. Now, as you can see, it's like the octagon has been squished. So there's our octagon done. Now the next one I'm going to move on to is the hexagon. Okay. So, and the hexagon will obviously contain the equilateral triangle. So bring down this. This has been brought down already. We only actually have to bring 2 more down. So I'm going to rotate them around. So at this point and this point, because they come from the edges of the hexagon here and here. So rotate them around. And there we have it. And once again, project them up as far as I'm going to need them, up to about here. I'm using this line as a guide here to tell me how far I have to bring it up roughly. And do the same then with the other one. And at that point then, project our points across. So there's our one here, here, and then finally at the top, that'll come across to there. And there we have our hexagon. So just make sure I plot my points first, but I'm just going to check them afterwards just to be sure that that's going on the right one. Yes, here and here. Then this one comes around, follow it up here and here. Yeah, I'm happy with that. So let's put in our hexagon. This one, and while we're at it, we can also heavy in our equilateral triangle. So I know at this point here they connect, and then they connect up to the top one here, there to there. So there's our equilateral triangle. Now finally, the last one we actually have to complete is, we know we have a circle contained within here, okay, that is touching all the points of the hexagon. I can actually find two other points while I'm at it. I could locate this one and this one, okay. So just to give me a guide, because I'm actually going to have to freehand in this circle, so I'm going to find some points to help me be able to do that. So there's two more points on the edge of the circle here, okay, and here. So once again, come back to our compass and rotate them around into position. So there we have it. There's two more points, and I know they're up along the center line, so right there and there. That's giving me two more points here and here, so that will kind of cover this portion. So what I really want to find is maybe a point here, 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 and here to be able to complete it. So to be able to do that, I can just pick a point. I don't have to exactly, I'm just going to pick a point that's in between this point and this point, so roughly in the middle. I'm going to use that point there, and that will actually locate a point down here as well for me. Okay, now you could obviously go off at an angle of 60 degrees. Yeah, you can actually see it's working out quite well there, but we can also just pick points. So from here, that'll give me 2 points, okay, technically, that I'm trying to find. This one and this one, and I'll do the exact same then, okay, by keeping the same height. I'll transfer this across, okay, two birds, one stone once again, so right there, and that gives me my 4 points, 1, 2, 3, 4 that I want to find. And simply then I can just rotate around 2 points to locate 4. So that's the first one. That's the second one. And we can see where we're going with this then. So this one here, I'll shake that up, make sure it comes up far enough, and the exact same on the opposite side. So it's up to about there, I'd imagine. And for these 2 points, this one and this one, I'm going to project them across. I think it's going to be here and here, but I'll just come back to check. So just to be sure, it's along this one, so it's along this line here going up, so follow that. So there's a point there, and then point there. I'd imagine then, just by the process kind of axial symmetry, using this line as an axis, it's the same distance over. But just to be sure, I'll check that this point and this point, if I follow it back, yes, okay. So there we have it, guys. We can actually see our 8 points on the circle, or sorry, at this point I think I have about 12 maybe, or 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's our points. So I'm going to quickly sketch in that, so I'll speed up the video. Right folks, so there you have it. That is the question completed there. Probably the most time consuming part of that question was probably the little bit of a circle at the end of it, okay? I like that question because it does give us a little bit of a recap on polygons, and these kind of things often do come up on this type of question, okay, especially in the junior cert at higher level, okay, on this rotations question. They'll often throw in like a polygon, okay, and maybe a circle or something. You find the center of a circle by bisecting chords or so forth, okay, but having a good understanding of your polygons, okay, will really help you with these questions here, okay. Hope you found that helpful, guys. That is the question complete.